Hi everyone, here is a video that will go through with you everything you need for your cheat sheet. So the test will be split up into 3 parts. So part 1 is on similar triangles. This will only be one question, so it's not a big part of the test. And then the rest of it will be on right-angled trigonometry and non-right-angled trigonometry. And these 2 parts are from chapter 10 and chapter 11. So for the first part, similar triangles, you need to be able to prove that 2 triangles are similar. And the definition of similar triangles is 2 triangles are similar if all corresponding angles are equal and all corresponding side lengths have the same ratio. So you can see that in this diagram here, that this angle corresponds with this one, this angle corresponds with this one, this angle corresponds with this angle. And then you can also see that with this diagram over here as well. Every side length is to a ratio of 0.7. So there's different rules you can use to prove if 2 angles in true triangles are similar. So the first one is vertically opposite. So that just means that this angle here and this angle here would be the same because they're vertically opposite. And also this one would be vertically opposite to this one. Your other rule is alternate angles, so it makes like a Z sort of shape, and this angle here is the same as this angle here. This also works as like a backwards Z as well. So this angle here would be equal to this angle here. The next rule is corresponding. So corresponding makes I see as a capital F, where this angle in here and this angle in here are the same. And the last one is co-interior, which makes a capital C sort of shape, and these 2 angles add up to 180. So you'll be given a question that kind of looks like this. Calculate the unknown side on a similar triangle. So we've got 2 triangles here. We've got triangle KLM, and then we've also got triangle JLM. So you've got a smaller triangle inside a larger one. So the first thing you have to do is prove that they're similar triangles. So I would say something about this angle here because it's a shared angle. So you might say angle L equals shared angle in both triangles. And then I can see here that this angle here and this angle here, this again makes a capital F shape, so these 2 angles must be corresponding. So I would say angle N is equal to angle M corresponding angles. Another reason we know that these 2 angles are the same is that they both have the symbol to say that they're 90 degrees. Alright, so now we need to calculate the unknown side length, so we need to calculate x. So I'm going to work out my ratios. So this 4 meters matches up with the 6 meters, so my ratio would look like 4 over 6. And then this x meters corresponds with x plus 3 meters. That would give you the whole length. Alright, now I'm going to solve for x. I'm going to times by 6 here, times by 6 here. So I've got 4 equals 6x over x plus 3. Now I'm going to move all of this to the other side, so I'm going to times it by x plus 3. So then this becomes 12x times these two together. Oh, sorry, 4x. 4x plus 12 equals 6x. Then I'm going to take 4x here and take 4x here. So 12 equals 2x, and then divided by 2, divided by 2, x is equal to 6. So that is how you do a question on similar triangles. Then for right angled trigonometry, you need to know Pythagoras' theorem. So you've got your a squared plus b squared equals c squared. So you would use this to try and find your hypotenuse. Remember, c is always the hypotenuse in Pythagoras. If you want to find one of the side lengths, so a or b, so if you were looking for a, it would be a squared equals c squared minus b squared. And if you were looking for b, it would be b squared equals c squared minus a squared. Now remember, with Pythagoras, the last step is to take the square root. So if you're looking for a, it would be the square root of c squared minus b squared. The next thing you need to know is your three trig ratios. So we've got here sine theta equals opposite over hypotenuse. Then we've got cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Now, remember, if this is theta here, adjacent is the side that's next to the angle. Opposite is the side that is opposite the angle. And your hypotenuse is always directly opposite the right angle. So then if you need to find the angle, so you use these three rules here if you need to find one of the unknown side lengths, and you use the inverse, so the inverse of sine, the inverse of cos, or the inverse of tan if you're trying to find the unknown angle. So you need to be able to use these rules to calculate unknown side lengths and angles in right angled triangles. Now, one more thing for this part of the test, you need to know the difference between an angle of elevation and an angle of depression. So an angle of elevation is if you are at the person here, you're looking up, so that's where the angle is. And the angle of depression is if you've got a horizontal line across here and you are this person, you are looking down. So this is really important for your problem solving type questions, especially if it asks you, if it just gives you a written description. So yeah, that might be a useful thing to have on your cheat sheet as well. Then the third part of the test is non-right angle triangles. So you need to be able to use the following rule to calculate the area of a non-right triangle. You use this when you know two sides and the angle in between. So its area is half A times by B times by sine C. Your next rule is Heron's rule. So you use Heron's rule to find the area of a non-right triangle when you know all three side lengths. So the first thing you do is find, there's two parts to Heron's rule. So the first part is the semi-perimeter. This is where you add up all the side lengths, so A plus B plus C, and then divide it by 2. And then you use this formula here to calculate the area of the triangle. The next one is using the cosine rule to find an unknown side length in a non-right triangle. So let's say I always call my unknown side length A, So remember when you're labeling triangles, so if your side length is lowercase a, the angle that is directly opposite it is going to be capital A. And you can see here, so I've got my side length C, directly opposite is angle C, capital C, and the same with B. So I always call my unknown side length A. So say you had a triangle here, and this was X. Actually, no, let's do it differently. Let's say this is 8, 4, and X. I would call this one A. Then I'd call this one B, and this one C. And this is the opposite angle, so this would have to be capital A, so I would need to know that that's 20 degrees or something. So labeling your triangle is really important. Now this is the rule. A squared equals B squared plus C squared minus 2 times by B times by C times by cos A. Remember again, when you're squaring it, the final step is the square root. So really this formula would look like A is the square root of B squared plus C squared minus 2BC cos A. You can also use the cosine rule to find an unknown angle in a non-right triangle. So, this is the formula here for when you're trying to find an unknown angle. So you would use this if you know all three side lengths. So you might have a triangle like this, and we've got, let's just say 5, 6, and 7, and we want to find this angle here. So I'm going to call this length A, which means this length here would be lowercase a, then go lowercase b, lowercase c. Now, this is really important that you label your triangle correctly for this rule, because it is very important that you label the a correctly, because it's b squared plus c squared take a squared. So it would be 5 squared plus 7 squared take 6 squared. And again, with this rule, remember when we're trying to find the angle, same as with the right angle trig, you take the inverse. So to find that angle, it would actually be cos to the minus 1 b squared plus c squared minus a squared on 2bc. Then you can use the sine rule to find unknown sides, and this is just again, it's using ratios. So this ratio, say this came out to be 1/2 this ratio, the ratio of this side length to this angle would also be 1/2, and the ratio of this side length to this angle would also be 1/2. So the ratios are always the same. We only ever need to use 2 of these, so we might use the A and B, we might use the B and C, or we could use the A and C when we're using this equation. So for example, if this was, let's say this is 30 degrees and this is 5, and then this is 110 degrees, and then this length is x, so we would only be using the A and B part, and it would look like this. It would look like x over sine 110 equals 5 over sine 30, and then to get x by itself, you would times it by sine 110, times it by sine 110, and that would give you, you'd put this part in your calculator and you'd get the value for x. So then if you want to find an unknown angle, so say we had a triangle like this, and we know that this length here is, so this is 40, and let's call this one theta. Let's say this length is 7, and this length is 10, and we go A, so that's lowercase a. Let's go, this one is B, which means this is capital B, C, and C. So I don't have anything to do with A, so I'd be using sine B over B equals sine C over C. So again, I'd just fill in my values. This would be sine theta over 7 equals sine 40 over 10. Then we times by 7 here and times by 7 here. And then the last step would be to take the inverse of sine. So theta would be sine to the minus 1 sine 40 times 7 over 10. And so that's how you use the sine rule. And then the last bit is just this bit of information here. So I would definitely write this down if you need to about when to use each rule. So it says here, use the cosine rule when you're given all three sides. So that would be to find an angle, or when you have two sides and an included angle, this would be to find the third side. Then when you're using the sine rule, you use this when you have one side and two angles and you're trying to find the second side, or you use it when you have two sides and a non-included angle. So that would be to find a second angle in that triangle. And then the last bit is you use Heron's rule when you have all three side lengths and need to find the area. Now, the last bit of information I'd give you for your cheat sheet. When you do your practice test, I would highlight and note any questions that you really struggled with and didn't know how to approach, and I would definitely prioritize putting examples of these on your cheat sheet. So if you find that you really struggle with the sine rule, make sure you have one or two examples on your cheat sheet that you can refer to. Let me know if you have any questions. Good luck, and don't forget on Tuesday we're going to go through the solutions to the practice test. Good luck!